Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The topics of this video are windshield wipers and power windows. Wipers and power windows are both like very well-behaved dogs. The wiper motor always returns to the home position and stops when the driver turns the switch off, regardless of where the wiper arms are. When the power window switch is tuned to auto up or auto down position, the power window moves up or moves down to a predetermined position and then stops. Moreover, these functions have been implemented since well before the era of electronic control began. This video reveals how windshield wipers and power windows operated before and after electronic control. Wiper systems consist of a wiper motor, linkage, and wiper arms. The automatic stop mechanism is integrated into the gear assembly of the wiper motor. The automatic stop mechanism consists of a worm wheel, a cam plate that rotates coaxially with the worm wheel, and 3 contact points. They bring the wiper arm to the home position. The worm wheel is electrically non-conductive, while the cam plate is made of metal and is conductive. As a result, electrical current flows only when the cam plate and the contact points are in contact. When the wiper switch is set to the low-speed position, electric current flows in the following sequence. From the battery, to the wiper switch low, the wiper motor, then the ground. This establishes the low-speed rotation circuit of the motor. As a result, the wiper motor rotates at a low speed. When the wiper switch is set to the high-speed position, electric current flows in the following sequence. From the battery, to the wiper switch high, the wiper motor, then the ground. This establishes the high-speed rotation circuit of the motor. As a result, the wiper motor rotates at a high speed. When the wiper switch is set to the off position, electric current flows in the following sequence. From the battery, to the outer contact point, the cam plate, the central contact point, the wiper switch off, the wiper motor, then the ground. This establishes the low-speed rotation circuit of the motor. While the cam plate is in contact with the contact points, the motor rotates at a low speed. When the contact points disengage from the cam plate, the flow of electricity is interrupted. However, due to the inertia of the motor, wiper arms, and linkage, they do not come to an immediate stop and continue rotating for a while. When the central contact point and inner contact point are connected by the cam plate, a circuit is established to operate the motor as a generator, applying brakes to the motor and bringing it to an immediate stop. Thanks to this function, regardless of when the driver turns the wiper switch off, the wiper arms will always come to a stop at the home position. It is astonishing that, despite nearly a quarter of a century into the 21st century, these low-tech devices are still widely used. Certainly, it's not that wipers haven't evolved. Nowadays, they are electronically controlled to operate optimally based on factors such as vehicle speed, rainfall intensity, and driver set intervals. However, automatic stopping remains low-tech. In some car models, significant advancements have also begun. They adopt new electronic control wiper systems that incorporate a rotation sensor within the motor to monitor the position of the wiper arms. This not only enables the automatic stop function but also allows for the control of operating speed and angle. As an example of electronic control, let's take a look at operational speed control. In conventional systems, there are brushes for low speed and high speed on the motor, and the rotation speed is controlled by changing the brush through which electricity flows. In electronic control wiper motors, the rotation speed is controlled using PWM. PWM stands for pulse width modulation, a signal that alternates between on and off at a consistent cycle. The motor speed is controlled by changing the ratio of on and off. Currently, a pulse signal is being input with a ratio of 1 for on and 9 for off, causing the motor to rotate slowly. As the ratio of on is increased, the rotation speed of the motor will rise. Through PWM control, electronic control wipers can seamlessly control the rotation speed. This beloved low-tech device, having lived a long life, will someday fade away. While digitalization lagged behind for wipers, power windows began electronic control in the 1990s. By incorporating a rotation sensor within the power window motor, the control unit constantly monitors the motor rotation and determines the window position. This mechanism added some functions to power window systems. The auto-up function was implemented even before digitization by adding timer circuits or current detection circuits. However, with electronic control, the auto-up function is implemented without the need for additional circuits. In electronic control power windows, the uppermost and lowermost positions of the window are memorized by the control unit. It varies by car model, but in many cases, window position learning involves, with the window in the open position, pulling up the up switch to raise the window and holding the switch up for several seconds at the uppermost position. Subsequently, pushing down the down switch to lower the window and holding the switch down for several seconds at the lowermost position. This operation is performed at the manufacturer's assembly plant, so it does not require the driver's involvement. However, in cases where the power window has been disassembled, such as for maintenance, it is necessary to retrain the control unit with the uppermost and lowermost positions. The control unit counts signals from the motor rotation sensor, and it determines how much the window has moved from either the uppermost or lowermost position. When the power window switch is set to auto-up, the control unit raises the window, determines the uppermost position based on the signals from the rotation sensor, and automatically stops the motor. The anti-pinch function is a safety mechanism designed to prevent injuries caused by arms or faces getting caught in the window. When an object is caught during window ascent, the window's ascent speed decreases, and the signal from the rotation sensor is extended. When this phenomenon occurs, the control unit identifies it as an obstruction, stops the motor, and promptly reverses the motor to lower the window. For cars without window frames such as coupes and convertibles, the automatic window open and close function when the door is opened or closed has been implemented. When the driver pulls the door handle, the control unit lowers the window by the programmed number of signals. When closing the door, it raises the window by the programmed number of signals. This function is equipped to improve the sealing between the window and weather strip, and to avoid making contact with the roof molding. Finally, let's take a look at the principle of converting the analog signal generated by the rotation sensor into a digital signal. An encoder is connected between the control unit and the motor. In some cases, the control unit may also integrate the functionality of the encoder. As an example, the encoder is programmed to output 5 volts when the input voltage is above a threshold. If the voltage is below 5 volts, it outputs 0 volts, which is equivalent to not producing a signal. The analog sine wave signal is converted into a rectangular digital waveform by passing through the encoder, and is then inputted into the control unit. Thank you for watching. If you enjoyed this video, please consider subscribing to our channel. We'll see you in the next video.